Proportional relationships and equations. You should take these notes in your book. Our learning targets for this lesson are: I can write an equation in the form of y equals kx to represent a proportional relationship described by a table or a story. I can write the constant of proportionality as an entry in a table. First example. A recipe says that 2 cups of dry rice will serve 6 people. We're going to answer these questions and then make sure that we're able to explain why we get what we get. Okay, so if 2 cups of rice serve 6 people, then that is our proportional relationship. So we're thinking 2 times what value is going to give me 6. So to solve this, we would divide by 2, and our constant is 3. So when we go to figure out 1 cup of rice will serve how many people, it would be 1 times our k value equals what? Well, since our k value is 3, it's 1 times 3 equals 3. So 1 cup of rice will serve 3 people. And now we're at 3 cups of rice. So 3 times our k value, which is 3, equals 3 times 3 is 9. So 3 cups of rice will serve 9 people. And next we have 12 cups of rice. So 12 times 3 will give me 36. So 12 cups of rice will serve 36 people. And finally, 43 cups of rice. So that would be 43 times 3. Type that into the calculator, and that would give us 129 people. So 43 cups of rice will serve 129. And the last part here is if we generalize this and write it for n cups of rice. So we want any number of cups of rice. So what is the thing that is the same? That would be the 3. So the 3 is the thing that remains the same, and the number of cups of rice is the thing that changes, so 3n, and that's going to equal the number of people that it will serve. So P equals 3n. People equals 3 times the number of cups. Final answer. For this next example, a recipe says that 6 spring rolls will serve 3 people. Okay, so in this case, a little different situation, 6 spring rolls for 3 people. So that would be like saying 6 times whatever our constant is going to equal 3 people. So therefore, we would like divide by 6. And then our constant k is 1/2. So now we can apply that idea as we're solving the rest of these problems. So how much will 1 spring roll serve? So that would be like saying 1 times 1/2 is going to equal 1/2. So how many people will 1 spring roll serve? Half a person. Next one, 10 spring rolls. So that would be 10 times 1/2. So 10 times 1/2 is 5 people. So that would serve 5 people. Next one, 16 spring rolls. So 16 times 1/2 would be 8 people. And the next one, 25 spring rolls. So 25 times 1/2 would be 12.5 people, 12.5. And finally, we would like to generalize this for any number of spring rolls and people. So how many people will n number of spring rolls feed? So the number of people is going to equal 1/2, because that was our k value. That's the constant that is the same in all the problems, times the number of spring rolls. And that would be our equation. For this next example, a bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. Some days they make big batches, some days smaller batches, but they always use the same ratio of honey to flour. So we're going to complete the table. In order to do that, we need to find our constant. So K is going to be the second column divided by the first column. So we're going to take 10 over 8, and that's going to give me 5/4. So we're going to use that, and we're going to just multiply that. So 1 times 5/4 is going to equal 5/4, or 1.25. Next one, we're going to go 16 times 5/4, and that's going to give us 20 cups of flour. And then we have 20 tablespoons of honey times 5/4, and that's going to give us 25 cups of flour. And the last one is to generalize it for H. So H times 5/4 gives us 5/4 H. So therefore, question 2, if flour, F, is cups of flour needed for H tablespoons of honey, write an equation that relates F and H. So the flour is going to equal 5/4 times H. And that would be our equation that generalizes them both together. How much flour is needed now for 15 tablespoons of honey? Now we can just put in whatever we want. We can find the flour when we put in 15. 5/4 times 15. And that would give us 18.75 cups of flour. And the last one says 17 tablespoons of honey. So flour is going to equal 5/4 times 17. And we can type that into the calculator and get 21.25 cups of flour. So now thinking back about what we just went over, we looked at a relationship between cups of rice and people served. The constant of proportionality for that one was K equals 3. And when we took that and put it into an equation, we had the people served was equal to 3 times the rice. And what did this represent was the number of people served for every cup of rice. And in a different example, we have been looking at proportional relationships where we know a plane is flying at a constant speed. What is the constant of proportionality in these cases? If it is flying at a constant speed, then the rate, r, is the constant. So the rate is the constant of proportionality. What does this constant of proportionality represent in terms of the context? Well, the equations that we have used has been distance equals rate times time, where rate is my constant of proportionality. So what does this represent? Well, it represents the distance plane travels in a certain amount of time. Based on whatever the constant rate is. So our equation is D equals RT, where R is just the same. Once we figure it out, it's the same always. And we have done problems like this before. This is just another example of a proportional relationship, just like the ones we did in this video. So that's it for your notes on proportional relationships and equations. Make sure you bring your questions to class where we'll do some more practice on this.